Hello, and welcome to Pro Knowledge Station.
Today, we'll solve a system of equations that looks tricky at first glance. We'll use clever substitutions, careful algebra, and check our answer carefully. Let's begin. First, notice the domain restrictions. Because of the square roots, x and y must be non-negative. This is important for every step of the solution. To avoid messy squaring, we'll substitute new variables for the square roots. Let it be the square root of x, and b be the square root of y. Then x equals a squared, and y equals b squared. This makes our system algebraic in a and b. Now rewrite the original system using a and b. We get a plus b squared equals 7, and a squared plus b equals 11. These are our new equations. Next, subtract equation 1 from equation 2. We'll do it step by step to keep the structure clear. Simplify the left side. A squared minus b squared minus a minus b. The right side is 4. Now, use the difference of squares. A squared minus b squared factors as a minus b times a plus b. Then factor out the common term a minus b. Since a and b are non-negative, a minus b and a plus b minus 1 are real numbers. To solve cleanly, we look for factor pairs of 4. 1 and 4, 2 and 2, or 4 and 1. We'll test each case. Case 1, a minus b equals 1, and a plus b minus 1 equals 4. That means a plus b equals 5. Now, we solve the two linear equations. Add the equations. 2a equals 6, so a equals 3. Substitute back. 3 minus b equals 1, so b equals 2. We can check the other factor pairs quickly. In case 2, a minus b equals 2, and a plus b equals 3. That gives it equals 2.5. and b equals 0.5. Let's test it in the original equations for a and b. Plug into a plus b squared equals 7. 2.5 plus 0.5 squared equals 2.5 plus 0.25 equals 2.75, not 7. So that case fails. Case 3 is symmetric with case 1, but it would give a minus b equals 4. And a plus b equals 2, which is impossible because a plus b can't be smaller than a minus b when a and b are non-negative. So only the first case works. Now verify the solution at equals 3 and b equals 2 in the system. A plus b squared is 3 plus 4 equals 7. A squared plus b is 9 plus 2 equals 11. Both equations check out. Finally, convert back to x and y. Since x equals a squared and y equals b squared, we get x equals 9 and y equals 4. So the solution to the original system is x equals 9 and y equals 4.
Don't forget to like this video, share it with your friends, and subscribe to Knowledge Station. Thank you for watching.